Alright, so in this video we are going to begin to show you the magic that we can do within MATLAB. This is really kind of peeling back the curtains on what is possible and the difference between this and many other interfaces. And it's the seamlessness by which we can recreate what MATLAB does. And maybe that's an exaggeration, but I love the fact that we can create functions, user-defined functions within MATLAB, and the power behind that is phenomenal. So there are two ways we can do that. I've hinted at already the anonymous functions. We'll cover that later, but I think the real one that we want to focus on, the one that's a little more involved, can do a lot more, but is a little strange to first see, is the function files, the M-file functions. And there's a specific way you create these, but once you learn the formatting of them, everything else will click into place. So, function formats. Everything in MATLAB has a specific, functions have a specific format. If you think about it this way, the sign function, I don't have the variable. The sign function, it takes an input in here. All functions will take inputs in parentheses after the name of the function. Parentheses usually comma, it could be multiple data points. It'll be comma separated by those values, and it'll have an output. Something that's going to be, in this case, it could be a single value that's going to be outputted. It could be like we saw with max, min, or the mesh grid. It can be multiple variables that are outputted. But all of these are creating creatable things, and we can use the function file to create this. So what is the format or syntax of a function file? First and foremost, we start the file with the term function, and that's it. We start with that. And then in that top line of the function, we are going to define the output, what we expect the output and input of that function to look like. So for example, if we're going to have a single simple function that's just going to output one variable, we just give it one variable. We'll call this variable in this output, we can call it output. For clean sake, we can call it buddy, or we can call it guy, or we can call it Jebby. So function Jebby. Jebby is going to be the output. The input now equals what we're going to call the function. We're going to give the function a name. In this case, I'm going to call this function, I don't know, let's call it note man. I don't know why, but we'll just call it that. That's the name of the function. And then within this function, we are going to give and specify what we expect this function to do, or the inputs that we want from it. Do we want one variable to input it? Do we want 2, 3? What do we want this to be? F, and so forth. But let's start with one variable to keep it simple. Function. Now that we've created that, now that we've got this function together, we are going to start by going in and actually typing in what we expect this to be. Now note, I can, in this function file, give a comment. And this comment, I can state what this function is going to do. So let's say this function will simply create a specific output for a we'll create a specific output based upon a simple polynomial equation, and I'll even define the equation. Let's say the output is going to be the function f of x is equal to 10 x squared or cubed minus 23. Okay, that's a silly thing to do, but that's what it'll be. We're going to begin that title of that function. Next, we can go ahead and actually give that function. Now what we're going to do, though, is say Jebby is equal to, and then we're going to say 10 dot times x dot to the third minus 23. End. Now, note And this is kind of beautiful because you can see what's happening here. First and foremost, function and end are tied together. The function is expecting an end. This is the end. This is the entire story of the function. Now, you can see here, this function contains all the information inside it that it can do. We have an x value. This x was defined here. So whatever a person types in Noteman, and whatever value they hear, that value will get assigned as x. And then that value will be equaled here, and it will be used to create this function. And Jebi, this is looking for Jebi. You define Jebi here, it's going to spit that out in the output. So let's save this to see what I'm talking about. So I'm going to say save. Now what you notice right away, it already kind of guessed what I wanted to call this. Very importantly, for this function to work, not only has to be defined here, but the name of the function has to be specified here. You have to be able to see it. If this doesn't match this, it won't work. So Noteman has to be the name of the function, because that's why I called the function. Now save. Now, let's go over here. And I just have to type it in as I would for any other function. If I said 10, I now have answer is equal to 9977. It's working as if it was any other function that was ever created that we've ever used in MATLAB up to now. Did not create a variable. You'll notice the variables we created, Jebi and x, don't even exist. They're not even here. They only existed within the realm of the MATLAB function. Outside of it, you just can't relate it, can't code it, can't other thing. If I said x is equal to 5 out here, and then I said Noteman 1, it didn't use 5 it didn't use the 5 function, or let me bring that up, in MATLAB, even though this is x input, it didn't use that. It used the one that I put in here because the variables in the MATLAB function only exist there, and it's all self-contained, and it just outputs as we want. There's a lot of power to this, and like I said before, some of the power comes in how we're going to define this function. So I could say Noteman, use fplot Noteman, and I can give the bounds from 0 to 5, and then plot this. Oh, and I forgot to, let's put this in. And let's bring that up. Wait, where's the move this along. There you go. There's and we have our function plot from the curve that we created. So using the Noteman function. So, and that's really the kind of impressive thing about it. And note, like I said, to MATLAB nowadays, there's actually functions in MATLAB. Some of the built-in functions that we have are actually, sorry, taking a quick sip of coffee as I explain this, but there's functions within MATLAB that are actually M-file functions that are in the code. There's only a few functions that are built into the actual infrastructure of it. A lot of the functions we use in MATLAB are actually M-files buried within it. One of the examples, but what's interesting, now that I've created Noteman, which is a really dumb function, but it exists, to MATLAB, it doesn't see it as any better or any worse than any other function. It is now just part of its milieu code. As long as MATLAB knows to look for it, or knows where it be, it can run it. And if I said Noteman, help Noteman, like we did with any other function, you'll notice that line that we created in the beginning of it is now its help file that we can output. So it's actually all part of the same ecosystem that we have here. And I encourage you to kind of explore some of the file structure. If you have it saved locally in your own, if you bought MATLAB, you can actually explore the file structure, and you'll find dozens and hundreds of function files like this that it uses internally to create this. And this is, like I said, the real interesting power and utility behind the function. Now, let me go one step further, because I think seeing this a couple of times will help. So I'm just going to do one more example, one more slightly more complex example, just so you can see what I'm talking about, what I mean. So, before I do one, okay. So I can create a new function, and this function, I'm going to have it be two outputs. So in this case, I will say the outputs are going to be red and yellow. I have no clue why I'm calling it these things. This is just what's coming to my mind. And we will create a function called that time. And there's going to be 3 inputs to that time, an A, a B, and a C. Okay? Now, this function is less useful than Noteman. Now, I'm intentionally using simple examples here and silly examples just as a way to show the format, because I think the format confuses some people, and I want to make sure that the format makes sense to you, and then we can start giving examples that have more utility. But in this case here, I can actually have a function called orange. I'm going to say orange is equal to A plus B plus C. I'm going to say red is equal to A plus B, and yellow is equal to B times C minus orange. I could say minus orange, or I could not. Let me just not even mess with orange right now. We'll just do it at that. End. Okay. Save. And that time, save. Okay. So now that we have that function set up, that we have created it, we have that time. If I do that time, and I go 1, 1, it's going to get mad at me. Why? Because it's expecting 3 arguments, inputs. It says it's missing something. So I'll have 1. Now what happened here? You notice from the function, it has 2 outputs, but it only gave me 1 answer. Now remember, red is A plus B. Answer is 2. And like any other function that has 2 outputs, it defaults by just giving you the first one. If I want both outputs, I have to ask for them. So I have to say, let's say x and y is equal to that time 1, 1, 1, and now I will get both outputs. If you look here, yellow is B times C, which is 1 and 2, which is 1 times 1 times 1, so it's 1, and 1 plus 1 is 2, so that's right. One other thing you'll notice here is I have a variable called orange. It created it inside the function. It exists for the time the function ran, but once the function was done, it's gone. And since we never used it, there was no output to it. So even though we defined it, even though it existed, and even though we could theoretically, we could say divided by orange. I'll leave it like that for now. And I save this. Now that we're using it, I can rerun this. And now you'll have B times C, which is 1, and then 1 divided by 3, ABC, is 1/3. Orange is useful. We can recreate that function and get an output and use it later on, but it's gone. It's never going to be outputted because it was never requested to be outputted. And this is really the power and utility of a function. You don't have to waste your workspace and all this extra data with things you don't need. Now notice, the function that we have here is, notice the key part of this function here is we could theoretically, I'm doing one single value, but we could theoretically input these as arrays still. So if I was to say, let me get out of here. If I was to create an array, let's see, let's say Alright, so if I was going to create, say, 3 arrays, and I wanted to just do this like we would expect with any other kind of array form. So I can say T1 is equal to 1, 2, 3, and then I could say T2 is equal to 5, 6, 7, and T3 is equal to 5, 4, 2, enter. Now, if I say that time, well, let's get both the information out. So I'm going to say x comma y is equal to that time of t1, t2, t3. Run it, and you'll see something here. Well, 1, it created an 6, 8, 10, 9, 3 values in the array form, but it only gave me 1. Well, the reason for that is because it did a dot divide in our orange vector. This should be an array, but it did a subtraction instead of a dot array. So we want to fix that with a dot and say save. And now if we rerun it, we'll get what we were anticipating, is each array position being functioned independently and not necessarily a matrix division effect that confuses and doesn't necessarily do what we want it to do. So this gives you a sense of what it is that we can do with these, and hopefully starts to explore or expose some of this information that is available to us. And hopefully I do encourage you to use this and see how this works and see what can become of this, because there's a lot more power behind this than what's even shown on the upfront. We will use the M-file functions heavily for when we start dealing with ordinary differential equations, when we start talking about doing integration, when we start talking about doing differentiation and so forth. A lot of these will require us to be able to define functions. And so take the time to learn this format, learn how they use this, and make sure you understand what this is about. One final point, the nice thing within MATLAB is as you start to make these more and more complex, you do have the ability to actually have it suppress information so that you can keep things simple as you're developing it. But note, this will still save as a text file with all that information there. This is only a display thing within MATLAB. So with all that said, we will end that there, and I will see you all on Tuesday, and have a nice weekend.